pi sigma g, sir.
2 pi sigma g. Only this much, huh? Yes, fine.
Yes, sir.
Yes.
Yeah. Now you see that the same thing I'll derive now using Gauss law. To bring that, so what was the effort we have put it? It was a huge no. First you should know ring. From the ring you should know disk. In the disk again you should put r equal to infinity. Everything what happened will minimize here. There's a last sheet. For you it appears finite. It's a last sheet. That's why the ends I'm showing it in this way. So if I show like this, ends means what happened? It's a large due to last sheet. So this will make it a plane diagram. It's a thin sheet. Okay, let's assume a Gaussian surface. What Gaussian surface? The Gaussian surface I'll bring like this. This is the sigma. No. Here you take the elemental surface n cap. Here n cap should be like this, and this is having delta s. Similarly, n cap like this, and this is the n cap, and what is the surface area of this is delta s. How field due to sheet? I gave one plane diagram. Can you remember? The field will be like this, no? Uniform. Okay, I get this, and is equal to 2 pi sigma g. We are very sure what happened already. We know some idea. This is the surface which I'm showing more interest here. Later on, I do coloring it. So it will come like this here. So again, what is our formula? Okay, I think this is negative sign I'm forgetting because in electrostatics we don't use. Or you can show that E bar negative. E bar negative means it will be towards center. That's the meaning of that one. E bar dot ds. Yeah. Let's come for this one. What about there are three like what about the cylinder? No, shall I say the shaded part only will contribute the E bar? No, E bar dot d delta s will be non-zero only. What about here? E bar and n cap for this surface. For this surface, what is the value of E bar dot ds? Will be 0 because delta s bar will be upward and E bar will be tangential. So what is the like a E bar dot ds for by this surface? Will be 0. Only the flat surfaces will contribute. The shaded things only will contribute the E bar dot ds. What about this curved surface will not contribute here. Or you can give the name like this. This is the surface 1, surface 2, 3. This is 4. We'll expand like this. E bar dot delta S bar equal to 4 pi g net mass enclosed by Gaussian surfaces. So what all this due to? First one, E bar dot ds, negative sign, due to 2. We'll keep on write it. Now what is the net mass enclosed? Sigma into delta S, sigma into delta S. No, you can see that this cylinder will enclose the mass here. How much? Sigma into delta S. This cylinder will enclose the mass sigma into delta S. So here, how much of mass is enclosed here? So we'll get it. So what is the value of this? This will be minus E into cos of delta S cos of 180. because everywhere E is constant. We know it's a uniform. At all points on this surface, delta S, at surface 2, the E is constant, so E will come outside. Integral of, like a integral of that one, so it will be delta S, that one. Okay, then what about at surface 2? Will be 0. Any reason for that? E delta S, integral delta S into cos of 90 degrees. Due to surface 3 will be E delta S plus this will be, I think for everything minus sign will be there. In books, if you see for with E showing negative, E showing negative means it will be towards the body, that one. So let me eliminate that negative sign. Again, you'll get confused. Equal to how much it will be? 4 pi G 2 sigma delta S. Any Gaussian surface you assume? If you get answer, okay, fine. You assume correct Gaussian surface. Sir, integral delta S, the overall area, how much it is? Constant, no? Equal to area of cross section. Or some of you are asking, sir, why this is? I'll do one thing. Integral of ds what will give that cross sectional area. Let it be this much. Delta S, again you will get confused. So what is the value of this? This will be E delta S minus E delta S. 4 pi sigma 2 sigma delta S. So what all I can cancel out? 2 delta S will get ended up, no? So what is the, our entire formula will be 4 pi G sigma. 2 pi sigma G is what I got the answer. Anybody? Where is the mistake? What we are doing? Where we are going wrong? I'm just asking. I want to draw some attention. Intentionally, I made some mistake. Let's see that how you answer this one. Where we are gone wrong? See, there is only one mass. No, what is the mass present in the cylinder? Is what this mass only. If you stand from here, what is the mass enclosed? You say sigma delta S. And if you stand from here also, sigma delta S. The same mass we have written twice.